Welcome. I just see one issue with my stream setup. Let me quickly fix that. I saw that 1 split second too late. Here we go. Now we have awesome music. Perfect. Welcome to part 5, I guess. Today we are going to do the belts. I'm really excited actually. Let me just show you what I have here. So there was a bit of progress since the last time. So firstly, I swapped the filament. That's kind of like the obvious. Like we used to have this blue here. This was PLA, and we had splitting issues here, which of course was not ideal. I tried around a bit, and like the observation I had is that when I printed this with the black filament I have here, which is ABS, that I didn't have the splitting issue. I had it here, this yellow one is also PLA, I had it here, like exactly in the same spot, very reproducible. It's always like splitting like this. Like it's printed basically in this orientation, so my hand being the print pad, and yeah, of course, like this very weak orientation for this type of split. So this doesn't work. So yeah, basically what I ended up doing was kind of something I was playing around with before. Is I printed in ABS, and I did not have any problems with this print orientation with ABS. Like this was my test piece here, all fine and well. So that was my kind of like intention, or like my trigger to like swap out this filament from PLA to ABS. I think it should have done that from the start, but yeah. Now it's kind of official. So I actually ordered this filament here, which is like Polymaker ABS in turquoise, and it's a bit different color, of course, but it's still like the combination with the black. And this will be not the accent color we will be using moving forward. Unfortunately, for some reason, like the black ABS I use is Form Futura Titan X, which is like marked as like stronger than normal ABS. Maybe they are right. Because after I printed the corner piece again with the Polymaker ABS, like I still have the exact same split. So this did not work. This did not fix the issue, just swapping the material. So the next attempt then basically was, and it's actually like the other corner piece, turn this around, I changed the printing orientation. So basically, instead of printing it like upward, my hand being the print pad, now it's printed from here, like with the layer lines going this way. Like maybe you can see it on camera, maybe not. But it's like printed in this orientation upward. So basically the change then is that instead of the layer lines having them in a relatively weak orientation, this printed in the same orientation. Like the layer lines basically go in this direction, so they wrap around the part that's splitting all the time. So yeah, so basically I printed this one in this orientation. It is fine, so that's good. I did not reprint the other side yet. I expect that we have some couple of other changes, and it's kind of it's holding, like it's not a big deal that it's there. But I also observed the same splits on the bottom side. So you kind of like see here. This has the exact same issue here with the same split and this position actually on both sides. So this had the same problem. Reprinting an ABS obviously wouldn't have fixed it because it didn't fix it on top. So I also reprinted the motor mounts in a different orientation. I actually see here, this is the brim I used. So this is basically printed from here this way up, which is quite an artistic way of printing this piece, because like the obvious orientation would be this, right? Because like it's perfect flat flat side on the bottom. But again, like then we have the splits. So printing it in this orientation basically gives us stronger layers for the rods that come in here. And it's kind of like a compromise, because basically it's still like this obviously is relatively weak now. Like not weak, it's like you can't like break it. Like it's still quite strong. And I think the trick here is like still like we are at the 45-degree angle going up here and here. The only problem I encountered was I added a little bit of like supports here. I kind of iterated on that a bit between two parts. So basically there's a teeny tiny bit of support that like fills out this this rod here. So we have to remove that. Same here. So you see from the bottom actually quite well, right? Like we just bridge this part here. Not a big deal, like super easy to remove. But yeah, it's still not quite there. So you see on the support here, like it curled a bit on the edge, and unfortunately, like just the corner of this piece here is not quite perfect. So yeah, maybe I have to optimize the supports here a bit, but for now, totally fine. So these are two parts for the motor mounts. So that's kind of like the first step. We have to swap them in, remove those. And then the other part, and I think it's actually like the big thing we struggled last stream with, was we did not get this to move. Like it was not moving. The good news is it's moving now. Actually, I have like two different versions here now on the rails, but this is moving perfectly. So what I did is a couple of things. So firstly, the proper rods arrived. So you see like this is slightly matte on the bottom here, right? These were like the original ones. And now the shiny ones are just like the proper chrome plated smooth rods, like what you're supposed to use. So basically I swapped them in for the x-axis here and for the y-axis. Because like my thinking was like, it's nice that we built everything cheap and with hardware, like hardware store components. But right now it doesn't work. Like last week it didn't work. So let's get rid of all the special things in a certain sense and just like make it basic and work. And then we can like swap in cheaper self-made components or like hardware store components to see what caused the exact issue. Because right now like we had like a lot of different components that were like untested and I wasn't quite sure where the problem comes from. I diagnosed a couple of different issues already. So one problem was that I think the bearings we had were just too tight. So these are like also the smooth rods, the proper ones. So these are the purchased plastic bearings and they are relatively tight. So I think what happened here is that the gantry wasn't stiff enough to support this like higher friction bearing in a certain sense. These are the normal ones with the ball bearings inside. I would not at the moment. This one uses the ball bearings like these, and this is like butter smooth. Like it's quite noisy, and I actually had to sort out a couple of those bearings because they lost balls and stuff. So it was like it's not good quality. But this is like butter smooth. This definitely works. Also, this one has the same linear bearings inside. It works really well. Yeah, but it's a bit noisy, so I would not like to use them. And then the other things, these are too stiff, but we still have on my printed ones. And there, I think the problem was that because I kind of oriented myself on those a bit in a certain sense, like these were also very, very tight on the rod, and I think they were just too tight. So basically, I think what we need to do is have them just a bit looser. Like these are a little bit looser and they wiggle a little bit on the rod. Like they are not super tight. Like what I was trying to do like last week was or like the week before was to find a combination of the bearing. Like these are +2, so 8.2 millimeter instead of 8. And they're like wiggling a bit. You can see it here, like they're wiggling a bit. But the funny thing is that this one is also wiggling a bit. So this one is not wiggling at all, but it's also like really, really stiff and hard to move. So I was like looking at this and I was like, okay, if those wiggle a bit, then mine can wiggle a bit as well, maybe. So these are like very easy to move. They're +2 and +1. +1 is a little bit tighter, like still like moves very easy. +2 is even easier. But then I found like another issue. Remember last time this like always like got like off square in certain sense, like what you see here, right? I can push this out of square. And in combination with the tighter bearing, this caused a problem where it like just got stuck on one side and then like it got out of square and then like everything was lost. By the way, those yellow parts are like experiment where I tried to clamp the bearings really tightly. But as you see, they're like completely gone. They did not survive that. But I think they have some printed bearings inside at the moment. And this works relatively well. But what I then discovered are two things. Firstly, the real bearing has pretty much exactly 15 millimeters in diameter. Like it goes a little bit below, a little bit above. You can see it's reflecting a bit, so it's like 15.15, 15.05, 15.02. Like they're like around 14.95 to 15.2, like that range. They're not perfectly round. The purchased plastic ones are pretty much spot on 15. Like they're really close around 15, 15.5, 15.6, 14.97. But then like my printed ones, and I think this just has to do with like shrinkage of ABS, to be honest, they're like around 14.7, 14.8. So they're like significantly slimmer. By significant, I mean like 0.2 millimeters, basically. But I think this is enough to make them wiggle a bit inside the XY joints block here. So what I just did actually now, and I just finished, I printed one that is ever so slightly thicker. So this one is modeled with 15.3 millimeters, and yeah, now we have 15.15. So I aimed a bit high, which is good. So now these are roughly the same diameter as the ball bearings. So I quickly want to test those out. So my goal is basically to figure out which bearing type do we want to use, because once we have it installed here and we start doing the belts, like it's a bit hard to swap them out. So that's one thing we need to figure out now. And the other thing I diagnosed, that was the last thing, is actually like those are a little bit differently designed. These were the ones from last week. And you see they have like 2 sections here. And these have 3 sections. And now basically what I noticed, if I move them out of square, you see like there's a gap opening here, right? Between like these like blocks and the other part. As I push it, this gap widens and shrinks. So basically what happens is, because the screws go like through those 3 blocks, the screws slightly bend over as I push them. With this part, it's a bit more extreme than with this part, but they both exhibit the same behavior. And I think this is also like partly why we had these like issues where when we pushed on the x-axis here, like in y direction, they just went out of square because the part like this was not stiff enough. This connection wasn't stiff enough. So basically what I did is I redesigned this part ever so slightly. This is a new one. So basically, instead of having the 3 blocks like this and tightening from the screws from the back, we now have the screws on top and tightened down. So basically this should be stiffer in this direction. So where we have actually like the forces applied, this should be way stiffer. I have a second one, we just have to assemble that. So I hope that this is just stiffer and has less of the issues we saw last stream. And then the last change that just came from the ball bearings, there's ever so slight amount of grease now on the rods, and I think this also helps a lot with just like getting it going in a certain sense in the beginning. Like also with the printed parts, but technically you shouldn't use grease, I think. It just keeps like initially helps to reduce the friction. So I think it's good to just have a little bit of grease on the rod. So my plan now basically is first let's figure out what type of bearing we are using. My favorite at the moment are the printed bearings, to be honest, because they're more silent than the ball bearings. They're cheaper as well. And the other part is basically they are more customizable, or like they're not as stiff as the purchased plastic bearings. And I think they should work relatively well. So let's quickly try out this one in combination with the new bearing block. So let's assemble that. And then basically, if we go for this one that I just printed, we need to print the second one. And while this is printing, we can swap out the motor mounts. we have to mod one more of our little stepper motors, because like to run the belt, basically the motors have to be in place. So we should mod that before putting it in. Yeah, and then basically once the motor mount's in place, the motors are in, the bearings are selected, and the new XY joints are built, we can start running some belts. So that's the plan for today. So hopefully, like, my goal is to have some sort of movement from the motors. Yeah. Okay, that was like a long introduction. So I guess let's just get started. Actually, let me also just quickly keep the bed kind of heated at 85 degrees, just like that it's like hot, and when we want to print later, like we don't have to wait forever. Then I would say let's assemble the second one of the new one, and then let's assemble one side with the new bearing with a slightly bigger diameter, and the other side we just use one of the other ones, but we just have wrapped like one like layer of tape around to just make it a bit thicker. Yeah, so let's just quickly take this apart. I also found my my driver, which makes disassembly a bit easier. So, and let's actually quickly check what bearing type I used in the yellow block, because I absolutely 100% forgot. But it's like this runs really well now. Like I have no clue what the like most likely last stream there was just a combination of things. But yeah, so now it runs really well. I'm pretty sure these are also printed. Yeah, this part's completely completely correct. What do we have here? We have, with a bit of tape, +4. Oh, interesting. Because now we only have +3. Yeah, the +4 run definitely better. But the +4 still like are not as smooth as the ball bearing. So maybe they're wiggling quite a bit. Maybe we should print like a +5 or +6. Or we go with the +4 for now. Let's actually, how long does this print? 15 minutes. Let's quickly print like a +6. I think I actually have one. Oh, I selected wrong program. I have this like massive graveyard of like different bearing size. I think this is +6 actually. Does it say? Oh no, this is -6. That's the exact opposite direction. Like I tried a lot of different bearings. Okay. This is kind of like a find Waldo situation. What do you have here? +6. This one's +6. Oh yeah, this, yeah. Oh, this is good. There are some with 2 rings. The 2 rings are the smaller outer diameter. This one has a bigger. So let's quickly slice that, and let's just quickly print that. Okay, then this is off, and we can observe it on the side. Let me just pop your chrome there. Here you go. Cool. Okay, then let's just disassemble that quickly, and then we can kind of like copy or like move over the heated inserts from this like completely wrecked prototype part to our shiny new one. I think on yeah, exactly. So here we have the screws on the back. Like this is really like the main change between the part we have on the printer at the moment and the part we are about to assemble. Like just like the screw moved or the screws moved. And also, what I already know, we have to be so careful, like with the ball bearings. Like they drop balls so easily when you move them onto the rods. So just try to not move it out of the rods if not necessary. I'm still not sure if I like the new blue color, like the turquoise color. I kind of liked the more subtle, like pastel color of the blue I had before, and this is way more punchy. Quickly. There's a random strain of filament, but I think now it's kind of somewhere in the print. Should be fine. Yeah. Let's not worry about this. This is also, these parts are really like done. It's like I think this PLA is extremely weak. Like I know PLA is not like the top engineering grade material, but for some reason, like, I mean, this is matte PLA. Maybe this is like even weaker than normal PLA, but it's like really brittle in a certain sense. Like layer adhesion is not good. At least it's my feeling. Potentially it's also my printing temperatures or something that I'm not printing it hot enough. But I'm already printing it like 220, I think, which is like quite high for PLA, at least in my books. Let's keep those are two that we have on the prototype here. Yeah, it's interesting. Like they're way easier when they're not assembled. I think like really the pressure that the enclosure or like the joint here puts on them really like, yeah, just increase the friction ever so slightly. Like, yeah. Let's see. I'm also still running out of screws. Like I ordered new ones, but not enough, I think. So we kind of have to like maintain our screws a bit. I ordered more now, so hopefully I really ordered. I think like of the M3x12s, I ordered like 150 now, so really like a lot. And of the heated insert, I ordered like 500, I think. And it's just like, okay, at some point I will need them anyway, so let's just purchase a lot. Yeah, so let's see today how it goes with the belts. I'm really like curious if these like printed bearing stacks like work properly. Will also be quite a pain, like if we figure out that they're not working and we have to replace them. Yeah, we don't have to touch this part actually. So let's just start moving over some heated inserts. I'm also fairly certain, like I'm now using 3 screws here to mount down these rods. I'm fairly certain if you only do the center one, it's already good enough. I think it's like a bit over-engineered or like. But I'm rather safe than sorry at this point. Just making sure that they're flush or like a little bit under flush, because I don't want the heated insert to stand out basically and be the contact point. There's a bit of warping actually, now that I look at it, like the corners pulled up a bit from the bed, but I think it should be fine. I think that's the last one. Oh no, there's one missing. There's one I always forget, the one on the bottom. Oh, I think actually I also forgot this here on this part, so that's something we need to quickly add. So this is complete. We have 3 here, 4 here, and 1 on the bottom. There's a lot of screws going into this. Then, yeah, we have to quickly take this apart, which we have to do anyways because we want to add the different bearing inside. So yeah, this one's also a bit warped. Loosen the screws, you can see it. So maybe I have to print them with a bit of a brim next time. Okay, it was not elegant. Oh yeah, we have a ball bearing inside here. And yeah, indeed, we forgot this. Let's steal. This one has it removed. This one has it removed. Let's steal one of those. And by the way, like I wanted to use those short ones for the Z-axis, but it's too short. Like I don't know what I thought by like ordering 20 millimeter ones. They're definitely not long enough. Oh, just park them on this side. I'll find something else to do with those. Then I guess we can already add this clamping piece here on top. Oh, I forgot, like I had to reprint this just before stream because this one is, with the old design, it used to be the same on both sides, left and right. But now with the new design, it actually needs to be mirrored. So I printed the wrong one. And this one fits. Let's just already add screws here. Now it's attached and we can later just clamp the things. Cool. Oh yeah, they're really warped. Now you can see it here. There's like this entire gap in the middle, but yeah, it should be serviceable. Then let's also already check. So if we use the +3, let's just try this out with 1. Like we use this +3 one. Just to make sure that it's like just a sanity check. Then we can compare it with the +6. That should be done in like 5-ish minutes, I think. And we can see which one we use. Just put this in here. And then we kind of have to like aim this here and it just comes together. But now there's also like way more of a gap with the larger outer diameter. Let's see. Oh, I'm really running out of the M3x12s. That is not good. Let's see if we can find some. I see at least one misplaced here. Maybe that's enough. I don't think we have any extra screws today that we need to assemble. Don't want to over tighten it. Just use our trial rod here. Yeah, this runs very, very smoothly. And it has very little play. Which I think is actually like not a big deal, because like later you have the belts like putting tension on that, and you have the second one on the other side that like kind of like stabilize everything. So I think this is actually quite okay, like the +3. Like the other one we now used, right? This was +4. Where did I put it? I have so many of those now. These are +2. Okay, I lost them. Never mind. Never mind. Okay. Let's quickly wait for the other one. But like, given that we already have quite a bit of play here, like I'm now wondering whether like these yellow parts compressed the bearing too much, and that's why we needed like a larger diameter. So maybe let's also try. Yeah, no, actually not having enough screws. Listen, we can seal some here. We don't need those. So let's just quickly cannibalize this part here. I hope that the new screws will arrive in time, but I had no luck. Let's just put like long screws in here. And we get 4 of our precious M3x12s. These are M3x20, which I wanted to use a lot initially, but I didn't use a single one so far. So we have plenty of them to spare. Okay. Then let's try. We had +4 in, right? I can't find them anymore, but these were +4. No, seriously, I have no clue where I put them. Oh, I put them on the thing. So these are +4. Let's just try them quickly and just compare the two. So this is +3 and +4. Yeah, this has way more play. Interesting. And I think like from the resistance level here, basically like this is like way easier to move, of course. Like, oops. But also this one like it's like sliding on its own basically. But what irritates me is like when we had this bearing in the yellow part on the rod, it was way harder to move. Just quickly grab this one. So this one is now +6. I think this is like way too loose now. Yeah, this is quite substantial play. Let's just quickly throw it in one of the bearings and just try it out. But then I think like this one is kind of like a golden middle. Yep. A little bit afraid to break this part here. Like I don't want to print this again. Be a real bummer. Trying to tighten it evenly. And to not overdo it. Okay, so yeah, this is super loose, but also in this direction. So this I think is not good enough. This was +4, so I think the +3 we have here is actually like a really good compromise. Plus like easy smooth, but it's not having too much play. So let's just quickly turn out one more of that part. Let's quickly jump up to Orca, and I think it was the one I printed before. So here, +3. Yeah. Let's just quickly double check that this is actually the part that we are looking at. Just to be sure, and then we print that while we replace the motor mounts in the back, and then I think we can already start. Oh no, we have to mod the motor as well, but then we can start with the belts. I'm really excited for the belt. Yeah, +3 with 1 ring. Yeah, exactly, that's what we are having here. So slice, remove the brim. My Orca gives me really odd errors sometimes. I'm also on Orca 2.0 beta. But I never saw this error before. Let me quickly restart Orca. Living on the edge. Wrong Orca. Here we go. Yeah. And print. Just to double check, this is the correct one. Yeah, +3. Okay. Then this will take like another 15 minutes to quickly finish. And there's a blob of material on the nozzle. Let me. Oh. Nozzle is cold. Let's heat up and then like remove the blob. Cool. Then this is good. Then I think this one we can already put together. Just double check. We have, yeah, we are missing some, yeah, like those teeny tiny spacer rings you see it in the middle. And we should make sure to add them everywhere. I'm not quite sure if I have enough tolerances vertically. But for now, let's add them top, bottom, and between. So this is complete. Here we have them. But we're missing it in the middle. Ha. Okay, so middle. Top. And bottom. Now we have to pay attention that one, basically like the two sides need to have mirrored stacks. So we have one rolling on top and like a spacer on the bottom. And on the opposite side, we need to have the exact opposite. So basically like the rolling on the bottom and the spacer on top. And the other stack on this side also needs to be mirrored. Okay. Put this together. For the last time. Just quickly check. I now got the blob on the nozzle, but I don't think it will get in our way. Cool. This is one, and then there's one extra screw that goes basically through the front stack, just like to stabilize this like little thing there. And it's a bit too long, but I tried to use as little hardware as possible. Don't have to tighten this pretty. Cool. So this is one side. The other side we have to wait for the bearing. So let's just start working on the motor mount. And let me get rid of all the bearings we don't use so we don't get confused. Okay. And let me also just add this stopper at these bearings here. I don't want to take off this version of the x-axis yet. Oh yeah, we also have to make sure to add the proper bearing stacks here in this now. Pretty sure they're a bit random at the moment. One. Okay. So this one on the corner is a bit special. Like it has two rollers because both belts basically go around the corner, of course. Actually, I have to remove the brim still. Let's clean this up a bit. I didn't dare to print this without a brim. Like the contact surface is so small. also very easy to clean up because like it will be covered by this corner piece here. Oh yeah, and there are actually two holes, which are completely brimmed up. I think this is okay. Like, still has a bit of elephant's foot, but that shouldn't bother us. Okay, and then we have to remove this like integrated support here. Should just be, yeah, quite easy to break and just peel out. Maybe not as easy, but okay, here we go. It's not too bad. So make sure to get this little here. Perfect. Here we go. And then we just have to like put in a million heatset inserts. Let's just copy them over from the old part. You really see like it splits like in all directions, like also here on the corner it splits, and pretty sure the new part will be much better. Also wonder whether we should already mount the motor, because now it's like very easy to like access it in a certain sense. Might be a bit trickier later on. Sure everything is flush. Then that's one side. Let's just try to... Oh, did I now do the wrong side? No. Just goes in here. Let's just start with the corner. We just later have to quickly check that everything is still aligned. Oh, this is the wrong part. This is the wrong side. This does not fit here. It's for the other side. This is the wrong side. This is the wrong side. Because like the cutout needs to be this direction. Okay. That's stupid. Then let's quickly put heat-set inserts in the other one as well. And we're done with that. That's why I really hate using brims. It's like such a mess always to clean it up. They're like those like I don't know how they're called, like those chamfer knives where you can just trace a corner. I think I should really get something like that. Here we go. The heat-set insert. I can actually also steal some from here still. So this one. Here are still some left. Inline recycling. Okay, two more. Oh wait, we forgot the hidden holes. And 3 more, and then we are done. And the bearing is also almost printed. So I think that we can put it all together. Now we just have to make the decision whether we use the printed bearings or the ball bearings from metal. Yeah, see, now this fits as it's intended to. One. And before we tighten the corner piece, let's put our stack in. So basically, I think it doesn't matter, like there's one roller and one spacer. I don't think it matters which side has which. Just needs to be the opposite on the other side. Loosen that a bit. Here we go. And then later we also quickly have to double check the spacing in between. Let's first roll everything together. Okay, and the other side should be quite quick because we have everything prepared, right? Nope. I really wonder whether I use too much screws on this printer. There was the stack. In goes the new part. Let's quickly check that we have all the spacers here. Yeah, we do. So the roller is on top on the other side, so it needs to be on bottom here. This goes here. Maybe I should get one of those like automated screwdrivers. That would save a lot of effort. Okay, so that is our new mortar blocks installed, left and right. And we have a bearing. So let's install our second XY joint, which I put over here. This one is still the wrong one. And we can quickly compare the linear bearings in the x-axis we currently have in. +6, remove that. Oh, we forgot. We forgot the stacks. So let's quickly build one. So we need one roller, one spacer, and the big spacer thingy, and then one spacer top, one spacer bottom. I squeezed it in here. No, I definitely have to undo that. And we also have to check the front idlers that they match. Could have done that before, but it would have been too easy. So here we need to be on top. Oh. Yeah. It's quite difficult. So the one on the back is roller on the bottom. And we need one more. Spacer. Maybe I should call those like tiny ones shims, although they are not. They kind of are. And roller on top. And everything is together. Roller top, roller bottom. Try to not over tighten this. And then our secret screw on the bottom. Yeah, some of them are relatively hard to roll. That's like what concerns me a bit. Like the alignment is one thing that concerns me, and then like the roll resistance, although I'm not quite sure how important it is. If the belts can like move over it quite smoothly, I think we are kind of fine. Okay, then I do have two rods we can use here as preliminary axes. Try to fiddle this on. It moves, but there's a little bit of friction. Just quickly preliminary put this together, that there's something on front. And then we compare the two sets we have. I will mercilessly go for whatever works best now. So if the ball bearings work better, then this is what we use. Put this together. We also have to like let me quickly also like get rid of all those broken prototype pieces flying around. Give me 1 second to like clean up this mess. Then let's tighten that. A bit of a special setup right now. if later we need to pay a bit more attention that everything's like square and aligned. Now let's just quick test. Also make sure this is kind of like free or like in the, so basically I'm always checking that like those are kind of like in their natural distance in a certain sense. Yeah, but no, this is exactly what we had last time as well. See, like one direction is easy and one, oh wait, we didn't, there's something missing. Would make sense to tighten those. Yeah, but still, like, it's not. Like, this moves very, very nice, and this is, I mean, it moves, but there's like, there's snags. And I don't know where they come from. Like, the other one we had was better. This one was better, but I don't know why, because this is even more loose. Okay, then for now we go with those, with the metal ones. The only downside now, we have to quickly disassemble those again. Okay. Sorry for wasting everyone's time with my attempt on the printed bearings. I had hopes. My hopes were shattered. Okay. Then let's get rid of those. And we need to be really careful with like adding and removing those from the rods. And these we don't need for now. And let's take apart. So here's our bearing. Ooh. Kind of done with assembling and disassembling those. Hi Adam, what print size will it be? Well, at the moment I'm kind of aiming for 180 by 180, so I'm not quite sure yet. That's the honest answer. It will depend a bit on how things align in a certain sense. Like I'm aiming for basically I want to use a Prusa mini bed. That's the answer. But it might not work out. So then potentially smaller. Just like the larger you go, the more problems you start. Oh, I forgot to screw on the bottom. The more problems start to arise, I think, because like if you make the frame larger, like it's easier for the frame to bend and stuff like that. And with the construction method I'm using, I'm a bit in doubt. Yeah, so basically it's like a bit of a tiered approach. So my core goal basically is to make like a sub 100 euro printer, which is more like a fun challenge than like a serious printer in the end, right? So we're going to use this like super weak 2 euro stepper motors. So we'll be super slow. It's more like a fun challenge to get to print with those motors. And then later on, basically, we swap in like proper motors. And for the, let's say for the sub 100 euro version of that printer, which will be like the initial build, we gonna use a 120 by 120 bed, just because of cost. Because like if you have only 100 euro of budget, like you have to flip every euro twice, basically. So this is one side. Let's very carefully slide it on. I lost so many balls doing that. Let's use this like as a stopper. And then to the other side. And I just hope that when we put everything back together, it still slides well and nice. And if that's the case, we can start with the belt. Just put it on the pile of death. Oh, actually, I didn't pay attention with the orientation of the bearing. So basically those bearings inside have like a cross of balls. So it's like four rows of balls. Here, 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 and here. Like basically like this and like this. 2 rows basically. And you want them to be on the rod in an X pattern so that no line of balls on top. But like you want them to be left and right basically. I think we have to quickly take this one apart again. Here we go. Stay here. I'm not having enough of here screws. Yeah, that was the worst way to take it apart. So basically, so if you look inside here, you see like there's one line of balls, right? And there's like four of those like lines inside. So we want to align them in a way that basically, if you look in, you see like 2 lines are basically now facing this direction. So basically none of the lines later when it's like attached like this is on top directly. Because if you run it on top because of gravity, basically, you're running only on one line or row of balls, which is not what you want. Now I should remember which part is which. This one's the old part. Okay, and this one's also old part. Then let's also now quickly check, because now that we take it apart anyways again. I'm pretty sure I'm making mistakes with the rollers. Which roller goes on top where? So here on the front idler we have the roller on top, and here's on the bottom. So I think the outer roller here needs to be on the bottom. Yeah, the outer roller needs to be on the bottom. So up. Let's put this in on this side, it's actually easier. This roller needs to be on the bottom. I managed to fill it in. Yep, just knew about that bearing X-line and Prusa Mini handbook too. Yeah, like I think it's actually quite important to get that alignment correct. Man, this is not giving me an easy time. Oh wait, actually, yep. Let me show you a bit more of what I'm doing. Sometimes they go in just fine, and sometimes they decide to give you like a really hard time. Here we go. Now it's in. And now I think from there on we cannot make any mistakes anymore if we just keep our mirroring strategy. So basically whatever we do on this side needs to be the opposite on the other side. So let's double check that the X pattern is correct. Oh, okay. X pattern is correct, but we lost the stack. needs to be on top. Okay. Let's actually maybe start with this screw here. Is there a way to determine the rod length for the y-axis that the bed will travel on? Yes, there is. It's basically simulation. I have fusion. So basically here I can just try it out. So this is kind of like just a movement link I made. This is the exact size I'm printing. And this will give me Gantry joints. Oh, no, this joints. The x-axis is this, whatever this is. So that's the rod length, which is 30 centimeters at the moment. Half of that plus 45. So it will be 250 millimeters, basically of left-right. But then you have to subtract the width of the printhead, basically. And the printhead is like 8 centimeters, I think. So this will be like 200 millimeters of movement in either direction, most likely. So it's a bit more than what we need for the Prusa mini size bed. But like my idea or like my goal is also to keep like the rod's standard length in a certain sense. And 25 centimeters is ever so slightly too less or too little. That's why I like settled with 30, which is a bit over, but yeah. I mean, you can scale a printer up and down. Like, it's really like all the rods. Like, if you scale up and down the rods, you can just change the print volume as you please. And if you cut them manually or you order them to size, you can, of course, use any size you want, in a certain sense. And yeah, the only thing that changes is like the belt length and the rod length. And then you can like do whatever you want, more or less. But for now, I just stuck with like the default 30 centimeters. So this will give us a bit over. Now this is like the thing, like this one doesn't run now nice. It's like, I don't know, like I didn't quite figure those linear bearings out yet. Like they give me really inconsistent results. Yeah, this one is exactly in the wrong orientation. Oh wait. This is in the wrong orientation, so we kind of have to disassemble it again. And also the stacks are incidentally correct. Yeah, the stacks are incidentally correct. Or accidentally correct. Okay. So I'm not quite sure if those bearings have like a good and a bad side in a certain sense, but like just before we now took it apart, when the bearings were in the other part, like it ran way smoother than what I have now. Like now it's a bit snaggy. I'm not sure why that is. I'll try to take this apart without dropping everything. There would be tremendous improvement. Success. And then we orient that in our X pattern and put it back together. I don't think it needs to be super precise X, but better safe than sorry. I love your color combination. Thank you. Originally it was this lighter blue. So I just swapped it basically now. This one was like a matte PLA. Initially I wanted to print the printer from PLA, just because it's like easier. Like it was really like a low effort, like low cost, easy printer to build. Just as a fun project, not necessarily to have like amazing printer. So I wanted to stick with PLA, but yeah, it's just not quite up to the task, I think. So now I swapped in this turquoise Polymaker ABS, and it's a bit more like punchy than the light blue PLA, but I really like the combination as well. Like it's quite cool. Okay, so this is all assembled. Let's quickly check how this behaves on the rod. Yeah, this one runs nice. This one runs nice. But this one, yeah, it's okay. Let's put it together and see how it feels. So let's remove those temporary ones. Put everything back where it belongs. Now let's just make sure that like it's like really on the end, and we need to make sure it's squared later. The other thing I really don't like about those bearings is like everything is oily now, or like greasy. Okay. Oh yeah, and those parts are glued, like there's still the old blue. But I used a drop of super glue to put them in place. So I'm not quite sure how I get them off, but most likely we'll have to change the front idler design anyways at some point, so I didn't want to spend the effort. And it's like purely like a visual part. Just like basically my thing is like, and also it doesn't match anymore. With the old parts, basically, you see like how it matches on the end, like this is exact same pattern, and then here's like there's still like a piece missing. So this is like the same pattern, and that was the same I had going for the front idlers, but that doesn't match now anymore. So the front idlers most likely we will have to replace anyways. So yeah, and then I think technically like this entire half needs to be this blue. Let's see. Yeah, I wonder whether we should like take this apart again. This does not run very nicely. And it runs bad in all directions. No, actually no. Not better. Weird. Okay. Okay, let's stick with it for now. Then on one side you have to quickly take off this part. And then very carefully add our x-axis. And one thing that's kind of annoying me, you see like this screw is different. Like all screws are the same except for this one. So let's quickly swap this out. Back. We have some random screws flying around, which is always good. Now they're all the same. Now I'm happy. Okay, let's just, this on the front is loose. So basically the x-axis should define the width of the printer. Like the way I mount those rods allows like for like a little bit of like wiggle room, left, right. Well, not left, right, but in the length of the rods. Because like most of the rods I cut by hand and my precision is not. Yeah, now it binds on the back, so we have to loosen that as well. So, turn this around. And then there's this bar here. I don't think we need it actually, but I just tried to stiffen up the frame a bit, so I added this like extra thing here. But I think we can remove this later on. So let's just first get everything in the correct width. So basically, now this can all loose. And basically the x-axis is just like the determinator of the distance here. So now that's at the back and everything is kind of like straight, we can tighten this. And then just flip it around. And then, yeah, it's actually some like another reason to like redesign the front idlers. We definitely need like something here, most likely. I had the hope that later, like when we have like the full printer with like the frame below, that we wouldn't need any like horizontal connection here. But I think the rods are not stiff enough to get away with that. So most likely it makes sense to have the front idlers also connect horizontally, just to stiffen everything up. Yeah, this is good. It runs very smoothly. Like if somebody watched last week's stream, like this is like amazing. I'm very happy about that. Okay, let's make another thing we need to check. It's basically that the distance of those two rods is kind of like the same. So let's just use a caliper on the front to kind of probe the width. Let's just check here. Yeah, that looks good actually. Yeah. Make sure that it fits between and like it's kind of snug. So basically we just have to correct it. Tiny bit too tight, so let's just loosen that. Tighten that again. Okay, perfect. Yeah, now it's better. I think technically it doesn't really matter if the top and bottom is super parallel. So far. Later this might be different. Cool, but I think then we're kind of now ready. Yeah, it's like a little bit rough on this side. I think for now it's fine. I'm also seeing myself taking this apart a couple of times more, most likely, until it's done, so. Yeah, but it's also good to check always, like, if you push it on one side, if it's touching on the other. Also, like, means it's relatively square. Actually, quickly make sure we have this pushed in. I think that the rods don't quite align. That's fine. Okay, cool. Then I think what we can do next is we can mount the motors. We have one motor, so basically we use those. Just bring in two. For the first iteration of this machine, like I don't just want to use normal NEMA 17 steppers, but for the first iteration we use these tiny motors. And I think now, like seeing how smooth this runs, we definitely will get motion. Will not be fast, but will be something. The problem is, like by default, these are unipolar steppers. What this means, they're just like working a bit different. So you see we have 5 cables coming out here, and we need to remove the red cable in the center. So this is the mod we need to do, and this is the unmodded motor. The mod allows 2 important things, 3 actually. The first one is we can run these 5-volt motors with double the voltage, which is 10, aka 12, with a bit of like wiggle room. Secondly, our printer mainboards are designed for bipolar steppers, so they only have 4 pins per motor. 5 pins on the unipolar motor is notably more than 4, so we need to remove 1 pin to be able to use like a normal printer mainboard. That's the second benefit, like we can use normal printer mainboards. And the third benefit is we roughly double the torque by doing that. The downside is technically they're like harder to drive. So if you have a unipolar stepper, it's easier to use. That's why those like low cost, cheap motors are unipolar by default. It's just easier to use them. And if you use motors like this, you're usually like in a really tight budget. These motors are actually like used for example, like in cars for like side mirror adjustments and stuff like that. So they're quite widely used. That's why they're so cheap, because it's just a volume product basically. And they're cheap because they're just not special in any way, shape, or form. So basically what we need to do is, here you can see it. We have to cut this trace here in the middle, which is kind of like the red wire connects to this terminal here, to this one, and then there's this trace to the back. So basically those two terminals are connected here with this trace, and then there's the red wire. So we remove the red wire, but we also have to cut the connection between the two. And this will separate to 2 windings basically. So just firstly, let's just snip off the red cable. Step 1. Red cable is gone. And then let's just cut the trace. I'm like trying to dig a bit into the PCB here. Make sure this is separated. Let's quickly verify that. So there should not be any continuity between the front and the back. There is not. Yeah, so we have continuity between those, but not between the center one. So we successfully modded this motor. It's a very difficult mod. I wonder now, should we just also quickly do the cable? And like basically we need to go from a 5-pin to a 4-pin plug as well, because otherwise physically doesn't fit. Let's get rid of this cap. Yeah, let's quickly do that. Then we are done with that. Just trying to get those pins out in a way that we don't have to recrimp them. Because if I don't have to crimp JST, I'm happy with that. I was trying to push in the little, oh yeah, okay. This one needs to be recrimped. It was pushed in way too far. I see we need multiple recrimps for that. Now this one is salvageable. And then the red one I don't care because we don't need the red one. Okay. Let's get rid of this red cable. And then most of those pins we can rescue. So just use a knife and kind of like bend them back. But the blue one is pushed in, so this one is gone. So let me just try to recrimp the blue one without losing like a lot of cable. And let's also be smart. And for a change, don't crimp the wrong connector on that. Because last time I remember when I crimped the other motor, I crimped the pond connectors on that by accident. That did not work. Oh wait, that's the wrong size. At least I noticed before crimping. That's the correct one. Usually do it like a 2 steps. First I kind of like push it on the cable and like push it together in the back a bit. Yeah, this is good. Successful crimp. Then we also need a housing. Let me actually just get this over here. This is my little crimping missing word thing. Let's just get it open. And then we just need to be careful with like the order of the cables. Then we kind of copy that. So basically looking at from the back, so we start with blue. That took me quite a while to figure out in the beginning for the first motor, which order is the correct one. And we have yellow. And then we have pink and then orange. Then pink and then orange. Cool. Now we have a functioning motor, hopefully. So let's put that on our printer. So basically we have those motor mounts here, left and right. And we have to assemble it in there. That's the one thing we need to do. And basically these are sized for a normal NEMA 17 motor. This is basically what will go in here. Because like eventually we will use proper stepper motor. It's like I kind of started this printer as like a fun project, just like for building it, but now I kind of also want to get like a somewhat usable machine out of it. So that's why I designed in a way that like we can accept those like super cheap steppers, but we can also like upgrade to like something proper. Then basically like one side we quickly need to check fusion, or like technically it doesn't matter, like we see it here. So one side basically we have this adapter that mounts on top, and then one side has the motor on top and the other side has the motor below. The reason is basically because we have two belts, right? The belts run on top of each other. One motor is aligned for the bottom belt and one motor is aligned for the top belt. So basically that's how it comes to be. This means we have to put in heatsink inserts here, of course. Two times, left and right. Let's just do it in one go. And then we mount them on those sliders here, basically. And then basically later on the belt runs this direction, right? Like it comes here and goes around. And then we can use this thumb screw here to pull the motor back, and this will like tension the belt. I stole that from the V0. Okay. 1 in, 11 left to go. Yeah. I ordered now, like I'm running low on heatset inserts again. Like I just ordered like 500 now. And I know like over time I'll just use them up for some random projects. Oh, actually we still have some to recycle. Just take some from here. The old parts. Grease everywhere. And the last one. I think I'm always bending the tip when removing them. Okay, I have to make it straight again later. No, it's fine. Okay, so we have a lot of pizza inserts. I would say let's just mount them on the things first. And because we're running low on screws, let's use M3x8, which actually is quite a good length for that. Let me actually quickly double check my fusion design, but I think they go on top. Let's just quickly check fusion. Is it a one-time project or planning to start mass producing it? Definitely not mass producing it. I'm gonna share the files and like make some rudimentary manual. I know one person already wants to build this as a plotter, like not as a 3D printer with Z, but just like as a plotter with XY. I mean, it's a fun project. I think, like, because like the part cost is relatively low. Like, if you can really spend like 100 euros and you get like all the parts together, plus like stuff you just have lying around, right? For example, I think there's like a lot of people having like an old Ender mainboard laying around because like they upgraded their Ender from like the 8-bit mainboard to 32-bit. And it's like if you have this mainboard laying around and you have, I don't know, a couple of screws and maybe some rods, you know, then you kind of have already quite a bit. Maybe you have an old laptop power supply to power it. So if you don't have to buy everything, like you can realize it for like a really small amount of money, and it's just like a fun project. Hey there, 3D printing junkie. Greetings back from the Netherlands. But so basically, like, I want to get it working now with those like cheapest motors, and then so for the 100 euro price point, basically, we need to get rid of the at least the linear ball bearings. So we have to use printed ones, which challenging at the moment. We have to solve that, and also like the smooth rods. Like you see, those are from the hardware store, and these are like proper smooth rods. So actually I have quite a bunch of different ones. So the shiny one in the center is like the proper smooth rod, which is meant for like a motion system. So these work best, of course. And then I also have like 2 different ones that I got from my local hardware store. And actually like these are like all the non-motion parts at the moment are hardware store. And they're super cheap. They're like 1 meter is like 2 euros. So it's like, they're cheap. But I think they're a bit too inconsistent for the motion system. Now I have hollow ones and solid ones. Yeah, but like they are fine for like building the structure, I think. But they're definitely not fine for the motion system because they're like, yeah, just like not smooth enough. Okay, let's see. The motor is facing this way. It's getting serious. We are starting to mounting motors. I really hope that we just get like some really rudimentary basic movement out of that today. That would be like really cool. Like it doesn't have to move like properly, or it doesn't have to move like the correct distance. Just like some movement would be really cool. Uh-oh. This doesn't fit. We can make it fit. Oh, yeah, because it's the wrong way. Or I thought like I made a mistake. It would be completely unprecedented. I quickly need to get the Allen key for... I always drop my Allen keys and my drivers for that matter. Oh. Yeah, we made a mistake. We have to first move them in here and then assemble that. That's the thing if you don't have a manual. I already noticed it with the switch bar I built. Like the moment you don't have a manual, you make the most stupid mistakes. Where it's like just like obvious that the order is wrong. And mostly it's also just a me problem. Now we have to pay attention. So this one has the roller on the bottom. So we also have to put the motor from the bottom. So this one is the right one. So let's just... Ooh, exciting. We have motors on the printer. I'm just really concerned that like the bearings, like not bearing stacks, but like these roller stacks we built from 3D printed parts, that they're not like aligned enough or like having too much friction. Because the motion system itself will be fine. Clip-on Marlin. So initially the plan was to use Marlin. So the root origin of this project was I don't have a Marlin printer at the moment and I need one Marlin printer for testing. So I wanted to have a very like stupid simple Marlin printer. This is how this entire thing started. But I think I will use at least initially Clipper because I'm just way more confident in configuring Clipper. Like if we have to make iterations and like I don't have a manual to go after here, right? So basically I just have to figure out what the correct configuration is. And this is just so much easier with Clipper. Like I think it's more logically structured, the configuration in Clipper, but also like easier to iterate because you don't have to like flash the board the entire time. So I think initially Clipper, but long term this might be like a Octoprint and Marlin printer. And actually, I kind of also want to try out RepRap firmware, which I never played around with, so maybe this is also like a printer for that. But at some point, actually, I also want to print, like, at some point in the next months, I also want to create, not a printer, but like a printer simulator. I want to use like 5 of those steppers just on a small board. I actually got a SKR Pico. Was on sale for like 20 euros, so I got one of those. So I want to use the SKR Pico, 5 of those steppers, and like the hot end just on a small board, just to have a Clipper playground, basically. RepRap is cool. Do you have any experience with RepRap? Or did you only see it online? Because like I saw it in some streams and stuff, but I never, or like videos, but I never tried it at all. And one last screw. And somebody could have tightened this corner piece here. Now I see it's completely loose. It's not super important, but let's get our screws tight. And here you see actually like where the overhangs went horribly wrong. But yeah, you can't really see it, so I'm cool with it. So those parts, like those motor mounts, I'm a bit proud. No experience. Okay, maybe it would be cool to like try it out on stream actually, just like trying to configure RepRap. Here, this is how I printed this, which I think is like really like exotic print orientation, but it gives like the most strength for this part. Oh, I want to move it. It's actually like also the corner pieces, like they were all printed in this like very weird orientation in this Y shape. Like, so you have tons of overhangs, which is quite interesting with ABS. It worked out quite well. No experience. The Stewart boards are expensive. Yeah, they're super expensive, but like they seem like, from what I heard, like they're really good, like just like technically. So I think it's worth the money. But yeah, maybe if you just want to try it out for fun, it's a bit too expensive. This runs a bit too well. Cool. Yeah, we have motors. I think that's a big step, right? Let's see in our goodie bag. Somewhere here. Yeah, we have idlers. Pulleys. Not idlers, pulleys. Yeah, this will be the tool head, by the way. It's a CR10 hot end with a Voron mini stealth burner Bowden setup. The hot end, by the way, like the entire assembly, like including the heater cartridge, the thermistor, the heater, like the heatsink, cable, Bowden, everything, costs like €5, which is, I think, insanely cheap. Like it's not a high-end hot end by any stretch of the imagination, but still, like, it's insane how cheap they are. Cool. Then let's pop the pulleys on. Hope that aligns. Let's see, this is a bit difficult to access maybe. Yeah, there's no like good access for this pulley screw. No. Oh yeah, I accidentally put it in the right orientation because like the shaft of the motor has a flat side. To be honest, like for those motors, it doesn't matter because they don't have any torque. Okay, so we have pulleys, we have all the rollers in place. So technically we can start like running a belt. I'm low-key nervous, but it will be fine. I got the cheapest belt on AliExpress, so sticking with the theme. I'm not quite sure how long one belt run will be. Like I have 5 meters of this very beautiful rubber, smelly, stiff, not nice. Like this is a high quality belt, like Gates. The one thing I noticed, like I'm not sure if I got the wrong one. It's that it has like those like fibers. You see like those like 5 fibers here? I know they exist as steel core, but I don't think this is steel. This is just rubber. But yeah, it has those fibers in the middle, and the Gates one does not. Color-wise, you can decide which one you like more. I think the brown is actually quite cool, but all black is also nice. Okay, let's see lengthwise. I think, I mean, technically the belt needs to go from the center, right, to the side, around the front, back, around the motor, like the loop, and then come back in the middle. So I think technically it's like one circumference, basically, plus minus a bit, right? So this is 30 centimeters. Let's just do 1, 2, 3, 4, and just add like a bit of extra. Quick sanity check. Yeah, that should be plenty. And then we need one identical length belt. I mean, later we will cut them anyways again, so I think it's not super important yet to have them exactly the same. But basically, having the same tooth count in the system is like the easiest way to ensure you have at least somewhat the same tension. Because like for Core XY, it's super important that you have the same tension on the A and B belt, because otherwise you're like printing not square. Like your XY will not be the same. I'm just like running them alongside each other so the tooths are like interlinked. Yep. Now we have two identical length belts. Let's run one first. There's actually not too much left. We need a bit more belt for the Z. So let's run one first. So we have those like teeny tiny blocks here. So basically, just put one side through. Oh, let's actually put both in. No, you don't see anything. I'm very sorry. Let me quickly fix the focus. For you? Let's just look at it from this angle. Fill that through here. And be a screw in the center of that. Will be a bit tight, but it is kind of the intention. And then we just put the block on. We will tighten that from the front, of course, in a second, just like to kind of like keep it in place. That right away. So now we just need to make sure that like the equal amount of teeth are here in front. I'm not gonna count them, but like it's exactly the same distance here. They're like exactly the same. We can tighten this. Oh, it's the wrong. It's the wrong way. There's the right way and the wrong way. You see, like there's a small chamfer here. Put it all the way wrong. And then I think the screw is not long enough. But because I designed for M3 by 12 and not the M3 by 8. So let's get rid of that. Grab a M3 by 12. Yeah, now it aligns much better. Let's quick double check. It's still the exact same length. And then we can just tighten it down. And now we have at least a bit of belt attached. Okay, so let's just get rid of one belt completely. I'll just run this here to the front. And now we kind of have to fiddle it through. So looking at this one has, we're running the top belt right now. So this has the roller on the front. So this goes through here. Oh. Make sure this is aligned. And we run through here. We have to put this later on the correct rollers and stuff. Then this one actually... oh no, it's correct. This one goes through here. So to make sure that we don't twist it, that would be cool. Then it goes around the motor pulley. No, that was successful. I think it's better to make a loop and then push the loop through here. Yeah, much easier. And then we go around the back. This is not really running smoothly right now. That is fine. And then kind of have to go through here. I think then this is like roughly a belt run. I think. If we didn't make a mistake, which I'm fairly certain we did. Okay, let me just double check. So we run through the front one here, so we need to run through the back one here. Let's just crudely fiddle that through here and attach that. Well, it's doing something. So let's make sure it's on the correct rollers everywhere. Because if it's not on the correct rollers, it's bound to fail. It needs to be on the top one everywhere. No, I did wrong. This is the bottom motor. This is not supposed to go around here. It needs to go around here. Oh, can I go? Oh. Oh, it's doing something. Let's double check. This is the top. Goes around the top and the back. Goes around the top here, goes through there, goes on the top here. Yeah, now it's correct. Now it's correct. No. Pulled it too much yet? Okay, then let's do the other one. Okay, it's something somewhat working. Just move this. I mean, you see already, like when I move it, like it's moving in the 45-degree angle. So this is what we want. Now this will be a bit interesting. I think the easiest is to push, because we kind of have to go this direction. I'm really sorry, like I'm kind of running out of space here a bit. Oh, okay, so let's pull this through here. And then immediately just push this through here. Okay. Then now here we are doing the loop around that motor. We go around the bottom. Go around the bottom. And we have to go all the way to the front, but we have to go through here. We go through here. Almost there. And then we go through here. I have to fiddle it through there, and then I think the belt run would be complete if it works, which I have doubts. Let's see. Okay, let's find some of those precious M3x12 screws. I'll actually quickly pull them out here before I lose them. Until my new batch arrives, these are like gold, basically. Okay, let's push this through from the front. And then there's this like little special piece here, which later will also hold the end stop, which is a bit of a special construction, but let's see, we need one. So basically I'm just checking that the length is identical, that we have enough, like the same amount of teeth in both systems, or in both runs basically. I think it's actually off one. No, it's just cut, not straight. Okay. Okay. Let's double check everything is somewhat aligned. Like I already can tell you this belt is really horrible. Oop. It's not on the right either. There. Ugh. Okay, now it's on the right one. Like those belts are like really like twisty. Actually, it's like gone later when we put tension on it. But at least everything seems to align, which I'm happy. Man, I have to put force on that. I mean, it's like mostly, hopefully that's turning the motors, which is quite hard. Because if this is like from like friction, we have a problem. Let's see. So let's actually make sure that they are both in the frontmost position here. And I think we can just tension them a bit. Bottom one can be a bit more. Just like doing this like roughly by feeling. I think we should pull like a couple more teeth because I'm already almost at the end of my tensioning here. Let's just loosen it completely again. And then just pull like 1 or 2 more teeth on the front. So let's use the long side here. Just loosen it and then like we can 2 more. Maybe. Yeah, now it's aligned again. Tighten it again. That works really well. Like I mean, I copied the geometry from the V0 again. Like this piece here in the front is like basically a modified V0 part because we mount the same tool head. So I kind of copied the geometry from there, but so surprised how well it works. Okay, then now let's tighten it a bit. This is the bottom one. I don't think we can tighten them too much because the motor plate basically starts bending a bit. But this should be fine. Okay, so now the question is, because this is insanely hard to move. Like it does move. Now the question is, let's just fire up. Yeah, I think it's best to just let the motors try to move that. Yeah, if you look from here, you see like how the pulley is bent. And it's flex from the mounting thing. Let's just keep the pressure tension a bit lower. Potentially we have to redesign that a bit to kind of support them from the bottom that they're not allowed to bend forward. Yeah, but it's also fine. Whew. Oh. I mean, it really takes a lot of force. Belts too tight. Do you think they're too tight? I don't think they're really tight. I mean, it's like really floppy. It's still really, really tough. But yeah, I would say like let's just try what happens if the motor tries to turn it, because I think the motor has a lot of like friction in its own. Maybe I should try 45. And now we skip here on the motor. But this is way easier. Of course, it's only one motor. Okay, let me quickly see. I did not prepare that well. So we have the main board we used last time. So let's just plug in. I actually didn't prepare it at all. That was not smart of me. But yeah, like I know from, I mean, if I now move to V0, this is super easy. So I wonder whether it's the motor, because like I know those motors are really hard to turn on their own. While doing my 2.4, if you take the slop out of the side, it couldn't even get the motors to turn. Yeah, okay. Maybe it's really just coming down to the different motors. Undo the grab screw on the pulley so you don't have to rotate more. That is a very good tip, Wes. Let me try that. This is excellent advice. That is my headset. 1 second. Okay, here we go. Let's undo the grub screw. That's a good one. I would also like if I now turn it here on the motor, it's like relatively easy actually. Okay, this one is loose. There should be a second one. I think it's... I fear it's not the motors. Okay, this one is loose. Also quickly get the mainboard out of the way here again. And this one is easier to reach. So it's one. Two. Yeah, it's way easier. Okay, it is the motors. This is not okay, I think. It's a little bit hard, but like, I mean, it's kind of to expected, right? Like, we are not using proper bearings here on the stacks, and I was wondering what the effect would be. That's actually, it works quite okay. Like, it's a bit tough, but it's not horrible. It's not horrible. Okay, let's tighten that a bit more. Just to don't have slop in the belts. But we already noticed we can't tighten it too much because like the motor mounts start to bend a bit. Okay, this makes it way harder. Oh, I'm also pulling now the pulley off. Okay, so we can't tighten that. So that's definitely something we need to address. Because basically as I tighten them, the motors, maybe you can see it. Ooh, that does not work. Okay. So basically the problem is now, yeah, you see the pulley, right? The pulley isn't aligned. This is partly to do with the way the motor is just designed, because it has like a super short shaft. So the shaft is like only like a couple millimeters long, so there's not a lot of like thing it can turn around. But then also like the entire motor like kind of like starts tilting this way. So we definitely have to like make this more sturdy, like the motor mount itself. So I think there needs to be something that like supports the motor basically from the bottom, that like it can't twist. Or just like around, that like something that we just like make this like a super snug fit. I mean, we have lots of space here, right? So we can just basically enclose the motor completely. And use longer screws. The things like the motor mounts are not super strong, because like my thinking was that later with like a NEMA 17 motor, if I use those, right? Because you screw it down on 4 sides, like it's really like constrained already with the metal plate, or like supported. Yeah, and it's also funny, like this turns so much easier than those. Like this is so much easier to turn. Which makes me wonder whether we should like stick with our like, because like also here, like, right, I kind of like, instead of going like from my cheap special parts that I need to make the price point work to like good parts later, I kind of like started with the proper linear rods and the proper linear bearings, and then like started like with proper parts and then moved down basically. So I wonder whether we should do the same here and just start with the NEMA motors, make sure everything works, and then swap in those like weird motors. because then we know like at least like the concept works. Then if it doesn't work after we swap the motors, we know it's the motors or like something with the motors. How are you controlling the length between X and Y when you tighten the belts? Do you have grub screws on the rods, or do the rods bottom out on the printed parts? So basically what I did is the rods here on X, they basically bottom out on the printed parts. And then like there's enough like adjustment width basically in those parts that you can have like plus minus a couple millimeters. So basically we loosen the screw on the back, also here in front for this one. We put in the X rods, we tighten that, and then basically we move it to the front, you tighten this one, you move it to the back, you tighten the back. So basically you just like the X axis defines the width, and then we just use it as a measure basically on front and back. Okay, so you know what we could also do? I just want to make sure that like, so there are a couple of components here in this motion system, right? So first we have those motors, and I think right now these are the main problem. But I also have those 3D printed stacks here. Like these are completely printed and rolling on the 8mm rods. So just to verify that the printed stacks are working, and that's my main concern actually, I would bypass the motors for now, so we can just like remove them from the loop. Then we just can try out how the motion system works, and then later we can swap in the motors. Potentially, like I'm really open to the thought of just swapping in NEMA motors right away. I have one loose NEMA 17 here, and then we can steal some NEMA motors from my switch wire for a quick test. Let's just, yeah, actually just pull this pulley off. Oop. And then we just pull this straight. Just quickly check that it's all aligns. Now we don't have motors, which is kind of like a deal breaker, but, and we can't tension. I'm just trying to pull this a bit tighter. Okay. Yeah, but overall, like, so my I designed the parts that like everything can kind of adjust also with the rod length. So technically, like even if those two would not be the same length, one is longer, of course, and then the other one is just like not bottoming out at the end of this part here. This actually works quite okay. Like the belts are super shit. That is, there's no way around that. They're not nice. And they're also not tensioned right now, which is another point. So if I just like manually like tension them here, this takes out like a lot of slop. Let me try to pull like a couple teeth more. I just don't want to break the part here. One, two. 1, 2. One, two. Oh. Yeah, we know at the point where like if I pull one belt, the other one snaps one back. Okay, let's tighten this. So this is the maximum we can tighten with this. Now you see like they're not straight, like they're kind of like twisting still, so they're not really like, I mean they're somewhat tight. But I think the belts are just really bad. Yeah, but I'm quite happy. Like this is as good as I hoped it would be. Interesting part would be like, do the rollers roll? The answer is no. So this might be also something we can optimize. So basically I'm just looking like in here. So if I move this, there's like the roller in the back, right? Really hard to see on camera, but I don't think. No, it doesn't turn like properly. So I think the friction is a bit too high. But I don't think I can optimize that, to be honest, like with the setup. There was like one thing I kind of like suspected, that like the rollers wouldn't actually roll. Actually see if I can feel this one in front. They're not greased. So here's a bit of my experience. I had problems with the lead screw on my V0, where it's a Teflon lead screw with a with a POM nut, like with a plastic nut. And there was a bad batch of lead screws, basically. I had one of those bad lead screws. And what LDO told me when I had the problem is that basically if you add grease to plastic parts, is that when they rub off, there's like a fine dust that is created, right? Like, so that you kind of like sand the part on the motion part, right? And this causes the grease, if you add grease to that, the grease captures the dust and like basically creates like how it's called in English, like polishing paste, basically. So like it captures the dust and makes the wear even worse. That's why I didn't add any grease. We can add grease. There's also like what I'm not sure if you looked or watched last stream, but like we tried to use printed bearings on the rods, and it didn't go at all like well at all. Now I had more success with that after I tried the normal like ball bearings, which are actually in here now. And I think what helped was a bit of grease on the rails, or like on the rods, because like these automatically like just put some oil on the rods. I think this helped. So potentially you're right, and a bit of grease on the rods would help. Maybe sewing machine oil or equivalent would work instead of grease. Also possible. I mean, I also have like WD-40 or something. It's a bit. Yeah, maybe that also helped. This one was not straight at all. I mean, at the moment it's also a bit the thing like there's the frame is not hyper square because there's just so much missing. It's basically just like 4 studs in the corners at the moment. Oh, this actually helped a lot. Oh, crazy. So basically this one was not straight. Let me also quickly check the other side. Oh, this one is fine. Okay. I mean, overall it works. So I'm already really happy. But you see here, like the belts are just like really. I think this also has like a big impact at the moment. You see like how the belts are like not. I mean, they're kind of tension, but they kind of have a life of their own. I'm fairly certain if I would have used better belts, this would also run much better. No, it's just sliding over the roller. Like if I just have my finger here and feel, like if I move it like this, and the bottom belt moves, like it just runs over the roller. Although the ones in the corner, I was already a bit concerned because I think there's a bit too much tension here. Let's try following. Let's just loosen those 2 screws here in the corner. And kind of like try to push this down Not that much, maybe. Just like a teeny tiny bit. Let me just that this has a bit more play. Because I kind of like think potentially I just have like not enough like tolerances vertically. Oh, you actually see it very well now. So if I now move this, oh, it actually rolls. But you see, like now, for example, like it didn't roll. Like, yeah, now it stalls basically. There's like this little print effect here on the corner. So if you look at this, it's a bit hard to see, but like it just slides over the. I mean, let's do the following. Let's just add grease to this one, right? And then just see what happens. We should be able to like sneak in some grease here without disassembling everything. Without making a mess, potentially not. Let's just pull this off. And then we can just move this. It's also like these are, it's actually really bad now that I think about it. These are sandblasted. I already like got like smooth ones. So this potentially also just hinders the movement that they're like sandblasted a bit. Let's just, I have grease. So let's just go for it and just add like a teeny tiny bit here. A little bit, oh, a little bit. Squeeze like a whole thing. They are ABS. They are ABS. Let's try to put this back together. But yeah, this is like one of my main concerns still, that they don't work. Like that this stack setup doesn't work. Because if this doesn't work, I'm kind of having a bit of a problem. So from like a project risk perspective, the stacks are quite high. I think it runs a bit better, but only in one direction. Yeah, if I push it forward, like it rolls quite nice. But I mean, the thing is, like, it doesn't have to roll, right? It just doesn't have to like provide friction to the belt. Maybe there's also just not enough friction between the roller and the belt to make it turn. Because like on their own, I actually don't have any left. Like these are a bit tighter. This is like one of the spacers. It's a bit tighter than the roller, but there's no like resistance whatsoever in like turning that. Like this is really easy going. Of course, like when the belt presses against it, I don't think it will turn harder. I mean, it's not as smooth as a bearing, of course, but I don't think there's a lot of friction between the rod and the printed part. Do you think printing some washers to go between the rollers might help? There are actually very slim ones. We have those in there. They are 0.2 millimeters. They are in between top, bottom, and in between the two. At least should be, if I didn't forget that. So technically, they should only, like, you also see they don't touch, right? There's like a small gap. Let's quickly double check that's in there. How are you trying to keep costs down? I know you're trying to keep costs down, but with flanged bearings such as 63ZZ at around 30 cents per bearing, it might be worth going that route. Yeah, I know. The thing is, like, it just adds up really quickly because you need a lot of them. And yeah, see here, there's like a washer in the middle. Maybe that's not enough and we need 2. That's also possible. Yeah, but Wes, so basically I know it's only like a couple cents, but the thing is, like, you need 20 or something, and that's already 6 euros. Or 30 cents, let it be 5. It's just like, all those like little things really add up. So this was like, I think one thing I hoped that I can like cheap out on. The problem is now if we would switch that back to like normal bearings, it would be a bit of a problem because, like, for example here, this especially, there's not really a way for us to mount the normal bearings because now I work with the 8mm inner diameter. Potentially, there are bearings exist, flanged bearings with like 8mm. I mean, the original idea, all the way original. Where did I have those? Let's see. No, I don't have any. Like, originally I wanted to use the 806, that like the roller skate bearings, you know, which like those like super cheap ones, because there you get them really cheap. Then my idea was to use them on the 8mm rods because they have an 8mm inner diameter, but they didn't fit on the rods. Like, it was just like tolerance wasn't properly enough. I mean, like, let's just try it like this. Like, I just like push them apart a bit here. Yeah, now it rolls much better. So there is not enough, there's too much pressure. Let's just try to keep this like apart a bit, that it can just like wiggle a little bit up and down, just like this, and let's do the same on the other side. What clearance have you modeled between the outer diameter of the tube and the inner diameter of the printed part, and is the tube aluminium? Yeah, the tube is aluminium. We can check the tolerances. I tried a couple different ones in the beginning. I don't know, I can't remember what I settled on. Just give this like a little play, like that, just like can adjust a bit vertically. Oh, this actually runs way better. Okay, so this helps a lot. Just like ever so slight gap there. I mean, now it can like move up and down a little bit. But it makes it much easier to push. The one in the front runs also much better. Just like I can see it kind of like from here. I'm quite sure if I can show it on camera. Like the front one also rotates quite well. So I think we just had those like pushed too far together. The thing is, I don't have any piece at the moment to like set that distance here. That's potentially something we should add, just as a feature. That like there's something in between the top and the bottom part that touches in the center to just set like a minimum distance in a certain sense. Because this is also like not like a horrible amount of like play now. This is also here like the same. Let's check the tolerances. And then I can answer your question. Wait, 1 second, I have to... Before I put grease everywhere. So I wanted to keep it relatively tight. My Fusion is not having a good time. So that's the stack. So for the rods, I assumed 8, but I know that the rods I use is over 8. Here's the measure. So this is exactly 8, but I know that the rod is 8.2. Oh no, actually it's below. Interesting, this one is 7.5. 7.8. 7.5. So okay, those rods are relatively, they're all too small. They're all undersized. By like 0.5 millimeter. Interesting. Because like when I initially measured them, I mean it's hardware store rods, so what do you expect? Yeah, they're all, wait. Oh, they're under. Wait, let me zero my calipers and then like measure again. So these are 8.1, 8.12, 8.14, 8.1, 8.07, 807, 8.1, 8.08. So they're all like 8 point, let's say like 8.1. So they're a bit oversized. And then the inner diameter of this one is 8.6. So it's quite a big tolerance. But also they're not like fully touching that. Let me. Yeah, I have a section available. This is how they look internally, which is not a good section. 1 second. Let me show you from top. Yeah, it's a bit hard to see. Uh, 20.5. Yeah, here you see. So this is how they touch. So they are not like fully touching it. They're only touching in these like spots, and it's all only like a millimeter tall, basically. So it's like a really small contact area actually. The reason why I designed it like this is that you have the seam. So you need to give the printer like the slicer needs to put the seam somewhere, right? The problem is if you have a perfect circle, the spot where you have the seam, the diameter will also be like will automatically be smaller, right? Because you always will have a little bit of a blob where the seam is. Like it will always come like out ever so slightly. So doing this geometry here, the seam ends up being in one of the corners here. And then basically like the inner diameter is perfect. And you only have that seam on the inside things. Let me see, can I... So if I do it like this... Yeah, you can kind of see it here. Wait, can I push that in? Yeah, here, perfect. That's what I wanted. So here you see it. So they only touch here on top, and on the bottom, in the middle, it's like hollow, basically. So it has a very small contact area. And then they have this like V slot, which in reality is like 2 layers, so it's not massive, right? This is like 4 layers high, this entire block here. But then basically, like vertically, they only, like in reality, I always put like the washer also in between. I didn't model that here, which is not ideal, but yeah. So they only touch in a very small area as well. You also see the washers, they only touch technically like this inner ring, not the outer. So they have really small contact area with each other, with the top, and also with the actual rod. So that was kind of like how I designed that. So it's also like why what I showed, like the spacer here, this one, you see a spacer like has a bigger tolerance, but has like doesn't have this like feature basically. So they are quite stiff compared to the actual roller. It's just a shame, like I don't have any spare roller left. We all put them in the printer. But yeah, this is like how the stack is like built. So I think it's reasonably okay. So I think, now the question would be, what happens if we add a bit more tension? Because like at the moment, like we don't have a lot of tension here, like they're relatively loose. So let's just, but we can't really tension them, we said, right? So if I just like, if I push them here, well, oh, I can't do that. They have to run, of course. Oh no, I can do that. Oh yeah, but if I push in, like it's much harder to. So I think tension breaks it a bit. But if I pull here, that's actually quite okay. The greased side runs definitely more than the non-greased side. So if you look here on this one, I'm sorry for everything black. So if you kind of, do you have like some marker? I only have black marker, of course. Yeah, okay. So if you look at this, you see it like, oh, you see like here, this like white spot. So it turns a bit, but not a lot. On the other side, you see it's spinning way more. So I think the tiny bit of grease actually helped quite a lot. Let's try to verify that on the other side. Push this down. Oop, we lost the stack. Let me actually just, I have like a bit of grease here on this paper towel. Already, yeah, maybe a bit more. Let's see. Yeah, they run way, way better. Okay, so that's then something we should do. Oh, I forgot the stack. The lost stack is lost. You need a roller on the bottom. Let's see if I can sneak that in here. ordeal, but I think it's almost there. Yeah, here we go. So potentially we should just go around and add grease to all the stacks. But overall, like, it runs really smooth, I would say. This stack doesn't matter, right? Because there's nothing running on it. But I wouldn't worry too much about that, actually. Like, even if the stack doesn't turn, like, this just means there's not a lot of friction between the belt and the plastic, right? Because also, like, if I look at this is like the Gates belt I have here. This has like a quite grippy backside, actually. Like, there's texture here. These belts are completely smooth on the back. I'm not sure if you can see it on camera, but like this one has like a leathery texture, I would say, and this one is completely smooth. So there's nothing just like to grip on the plastic, so I wouldn't worry about that. I think most likely if we run like the Gates belt on that same thing, most likely we'll have much more turning on the stacks, just like because like there's more grip between the plastic and the belt. The good thing is because of the reduced contact areas you designed in, you have somewhere for the grease to stay. Yeah, that's kind of like a grease pocket. So I think it's still worthwhile to just add like this like teeny tiny dot of grease on all the stacks. But I think I'll just do that tomorrow most likely, because we have to take apart the things again. So I think I'm still interested in like trying out what happens if the motor pushes the belt. The concern is just like the motor mounts are not stable enough. I think we have to work on this a bit because they're like quite wobbly in this way here. Yeah, now some screw is loose. Like they wobble around quite a bit. Like they're not super tight in their rails, which I don't think they have to like slide very well. Like this can be like a lot of friction. It's just like I think it's more important that it doesn't tilt, because like this makes like a degree of tilt. I'm not quite sure. Like, I mean, most likely later on the belt will just pull it forward, so I think it's fine. But it leaves us then basically with the mount for the weak motors here. Let's actually do the following. Let's get rid of this one and just put like the NEMA 17 in here, just like for quick test. That we see if the motor mount itself is okay, or if like there's the motor mount, right, and there's the adapter for the 28 BYJ. And I think the problem is at the moment that the BYJ motor is not stable enough. I don't think that the problem is the motor mount itself. Get those screws out. Actually, don't know why I keep this motor in this box. Let's just get rid of that. Flip that over. So my idea was really like, because you tighten this down in all 4 corners, like the printed part doesn't need to be super strong. Oh wait, this does not work. We need an Allen wrench for those. I think it's really like the problem that there's only like those 2 contact points, and if you not tension the bell, like it just like bends. If you pull this here, like it just bends up. I think like if you constrain it around the cylindrical geometry of the motor itself and just like supporting it in that direction, that it can't bend basically, or like tilt, that might help a lot. Okay, let's just throw this pulley on. Don't have to tighten it. The motor basically only functions as a shaft now. And then let's just pull belt through. This would be, I mean, it doesn't really matter, right? Yep, this would be the top one. Let's see, this is an interesting maneuver. Just get this around here. Now basically the bottom belt has a much shorter run, but this should be fine for quick testing. Okay, so now we just have the motor here. And let's just tighten that a bit. Yeah, we don't have the problem here with this one. A bit. But it's also like the belt is really weirdly. Here we go. Let me actually quickly tighten this, because it kind of like tends to pull up. Yeah, it's still tight. Like the motor is still like tilts a tiny bit. It's not as bad as with the small one. Trying to align the pulley. Like I don't have any alignment helpers, of course, but mark one eyeball does the job. Okay. Wait. Yeah, okay. Now I have to turn the motor. I noticed that. I was like, let's not tighten that for now. Okay, like it works relatively well, but you really can't tighten the system a lot. Like when you add tension to the belt, like too much tension, like the force needed increases a lot. No, it's still it's okay. Like it's not too bad. I'm primarily concerned about the like how the motor's kind of tilting or not tilting. I think it's okay. Like there's a bit of play in this direction. Like you can push it back a bit. But then like if I push there, like I flex the entire back here. But it doesn't start to tilt more. Like as I add tension, like it doesn't tilt more. That's kind of like the way tilted is. So I think it's just like the tolerance we have on this like slider mechanism. So if we reduce tolerance there, like technically I guess this should be better. But now as we add tension, like this becomes really hard to push. And I think this is not a problem with the bearings. Or like the, not the bearings, like the roller stacks. Because as we add tension, right, there's more friction between the roller and... Yeah, it's also like really because I add now tension on one side. Yeah, it's way easier to push without tension. Okay, so I think the grease we can quickly add it to all the stacks. Shouldn't take too long. But I think it's also like we don't need to have tons of tension on the system, right? Like the top belt here is already relatively, yeah, not really, quite sloppy. If we have something like this should already be fine. And this is kind of okay to push. Okay, so here's the plan. I would do a cut for now, or for today. I think the next step would be really to try to drive the belts with the motors. But I don't have the stuff right now that we need for that. Because I'm very well prepared. Because we need a raspberry, which I actually don't have ready, so we now need to flash clipper, which was not smart of me to not prepare that. And then the main problem would be that we have to redesign those parts. Just like constrain the motor a bit more to prevent tilt. Because the main difference here, right, is also like we have this really short shaft. So there's not a lot inside the pulley to support the pulley. It's also like a bit concerning. And then you see like it's really like bending down. So this needs to be improved. This needs to be improved. It's also like the top plate here of the motor, right? Like there's this one plate with this like thin metal sheet, and that like has to hold the entire like tension. So we just have to like support the motor from below, like grab it here. I mean, there's enough space, right? So we really can just extend this. Or like, most likely will be a second piece because we need one flat side to print, which is this one at the moment, because we have to raise it here a bit. So potentially it's just like second part we put on the back, and then like there's a longer screw just running through that part, like connecting the bottom piece with that. It also needs to work for both orientations, right? Because there's the second orientation here, where the motor is on the bottom. Yeah, I'll have to think about it a bit, but we have to make this like stiffer for sure. But yeah, besides that, I think this counts as a success. Like, it's running reasonably well. And I think if we add the grease to the stacks, it will like run a bit better. The only thing that's not funny to now see, like those two are not perfectly parallel. Like they come together a bit in the front, like it's more like a V shape. Which I don't think it's like bad, like a problem. What I also now see is like if you look in here, the belt touches a bit like the outside. I can show it. Like the belt here, where it like runs through that like shape here, the C shape. I think it touches a bit the wall. So I'm not quite sure if there's like hooks into that a bit, which would not be good. I don't think it's... No, it's not touching. It's barely not. Fine. Yeah, I think... I mean, a millimeter more tolerance there would have been nice, but I think it's fine. Okay, then I think that would be it for today. Thank you for tuning in. Actually, next week I have to skip because I'm out of town. So basically, the next stream would be in 2 weeks. And then, yeah, we start driving the motors. Potentially by then I have a second DEMA 17. So I think as a good first step, again, like let's stick with the approach to start with the normal parts and go down. I wished I would have done that for the stacks. I did not. And potentially we can also look into maybe replacing the stacks with like proper bearing stacks. I have to think about that. I think the main problem will be the one on the back. The other ones should be relatively easy to replace. Cool. Thank you, Adam. Then see you in 2 weeks. Enjoy your weekend. Bye.